Hello everyone, in this video we're gonna talk about the binary search algorithm. So how this binary search algorithm works, I will demonstrate you step by step, so keep watching the video till the end. We have this lead code problem. This is called the binary search. So this binary search algorithm, how do we construct or build this binary search algorithm? How does it work? I will show you step by step. So first of all, in a binary search algorithm, you have been given an array of any length. And the first of all, what you have to do, you have to just put on the indexes. Let's say this is the demo array we have, and there are the indexes on each of the elements. So it's the array of length and 8. So the length of the array is equals to 8, right? So 0 till 7 index we have here. So the first of all, what you have to do, we have been given a target. The two things will be given to you. The first is the array. The second thing is the target number that you have to search in the array using the binary search algorithm. So the first things first, what you have to do is that you have to place the two indexes, right? So the two indexes that you have to select is first index is the low and the second is the high. Now how you will gonna place them? The low index should be at the 0th index, right? So the low is should be placed on a 0th index and a high pointer should be placed on the 7th index or the last index of the array. So the high pointer should be placed on the last index. Now what you have to do, you have to just take the mid. You have to find the mid. How you will gonna find the mid of these two? So the first thing you have to do is to just take the index. Let's say the index is 0, of low is 0, the index of high is 7. So what you need to do, you have to add them, right? You have to add the indexes of low and high and divide them by 2. That means you have to find out the mean of the indexes of low and high. So the mean of the indexes of the low and high will be your mid. So the indexes of the final answer would be I guess 3. So the final answer would be 3. So 3 point something, maybe 3.5, right? So the you have to just select the whole number. So the if you use the floor function here, then you can see we will use the floor function here. So the floor function will make it equals to 3, only 3. So the mid value should be placing on the third index. So what is the third index here? Third index is this, the 10 element. The third index containing the element 10. So the mid is pointing here, the low is pointing at the 0th index, the high is pointing at the 7th index. Now what you have to do, first you have to check. First things first, you have to check whether this mid value, this mid pointer and this index contains the element, the required or the desired element. So we have 10 here, and at the target we need to find 20. So is it 20 and 10 equal? No. The next thing is to check whether this mid value is greater than or less than the target. So if we just compare it with the target, then you can clearly see that 10 is less than 20. So the 10 is less than 20. So what does that mean? 20 is greater than 10, right? So our target is greater than the mid value. So in that case, if the target is greater than the mid value, I'm just writing here, if the target is greater than the mid, so what you need to do, you have to just move the low pointer to the +1 pointer like this. I'm just placing it here. So the mid value is at the third index, so the low will be placed at the fourth index. And again, the high is at the same place. High will be at the same place. So if this is the condition, what we need to do is that we have to just make the low is equals to mid +1. So the low pointer will be equals to the mid +1. So mid was pointing towards the third index, and now in the second iteration, this will be low will be +1 to the index of mid. So now we have the updated low value and we have the same high value here. Now again, in this step, again, what you need to do, you have to just get the mean of these two. Now this time we have 4 plus 7. This is the floor function divided by 2, which is equal to what? 4 plus 7, you have 11. 11 divided by 2, that is the 5.5, I guess. So it will be equal to 5. So the mid value will be pointing towards the fifth index. So the mid value will be here, right? I hope you are understanding this. If you have any queries, so you can just timestamp and just ask it in the comment section. So here it is the mid value, and now again you have to check the mid value. Is the mid value equals to the target? We have target 20. Is the mid value equals to the target? No. Now the second thing what you have to check is the mid value greater than or less than less than the target. So you can clearly see that this 17 is less than 20. So our mid value is again less than target. So what do we have to do? We have to again, the target is greater than the mid, so what do we have to do? Low pointer will be incremented to the mid value. So in the next iteration, this will be pointing towards the 6, and this high will be at the same place. Now this high is at the same place, and what do we need to do? We have to again just check. Now this time we have 6 plus 7, which will be divided by 2, and which will be equals to 7 plus 6 is equals to 13. 13 divided by 2 is equals to 6.5, then it's equals to 6. So the mid value will be also pointing towards a 6. So mid pointer and the low pointer are pointing at the same index. Now what do you have to do? We have to just check whether this mid value, that is the 20, is it equals to the target? Yes, absolutely, this 20 is equals to target. So in this case, if the target gets equals to mid, then what do we have to do? We have to return basically the mid value. So the mid index, we have to return the mid index. So in that case, we have the return value 6. So it is the return value in this case. So this is how the binary search algorithm works. So this is the first condition. Or else, if I just told you the third condition, that what if the target is less than the mid. So if the target is less than the mid, then what do we have to do? We have to just high, change the position of high, and it will become mid minus 1. So this is the third condition, right? So this is the first condition that we have is the first condition, and this is the second condition, and this is the third condition. So these three are the main conditions that we will gonna use in the binary search algorithm. So I hope you understand this algorithm. Let's see, just make the code of this algorithm. What we have to do here is that we need to just make the low. The first things first, we have to make the low at the 0th index and high at the last index. So I will gonna last index, this is the nums list, and I will just put the high on the last index like this. The high will be pointing towards the last index. And again, what do you have to do? We have to just check this while while low is less than equals to high. While the value of low is less than equals to high, then what do we have to do? We have to just check the three conditions. If the target, we have to just make the mid. Now the mid value will be calculated as the low plus high, and it is floor function with 2. Right, so it is floor function with 2. And then what do we have to do? If the target gets equals to the mid, nums mid, we have to check the value of the mid. So if that's the case, then we have to simply return mid. Elif, if the target is greater than the nums mid, if the target is greater than the nums mid, or you can say that in that case the target was greater than the value of the mid, then what do we have to do? We have to just set the low to the new position, that is the position of the mid plus 1. So the low was previously pointing towards the 0th index and the mid was pointing towards the 3rd index. So we place the low towards the 1 index increase in the mid index. So mid was pointing towards the 3, now we will place low at the 4th index like this, right? So this is how we're going to do this. And else, in the end, if the target gets less than the nums, then what do we have to do? We have to just make the high is equals to mid minus 1. If there is a condition like that, if the target is less than the mid, so we will move high towards the mid, the less than 1 index of the mid, right? So this is the third condition, and these all are the conditions here. And else, if the number is not found, then we will return mid, return minus 1. In that case, what if the number is not in an array? That's a possible question, that what if the number is not present in an array? Then in that case, we will just simply return minus 1. So this is the whole binary search algorithm here, and let's just run this thing. And you can see that this is accepted. What is the time and space complexity of this algorithm? So the time complexity, if I talk about the time complexity here, then the time complexity of this algorithm is big O of log n. The time complexity is big O of log n. And the space complexity of this algorithm is O1, because it does not uses any additional space or any additional list or data structure. So this is how this binary search algorithm works. And if we just also see this code of the binary search algorithm, and I hope you understand this. If you have any queries or confusions, then you can definitely ask in the comment section. Thank you so much.